In this exercise, we're going to create a confidence interval again. Now, I don't particularly love the wording of this question. I should change it for next semester because it just says create a confidence interval for the parameter of interest, which doesn't give us a whole lot to go on. What are we interested in? And nothing in this question actually tells us that. So if we read, Consumer Reports randomly tested 14 brands of vanilla yogurt. Assume the population of vanilla yogurt calories is normally distributed. Since remember, as we saw in the last question, we have a small sample size that we can't have normality unless our original distribution was normally distributed, which they have told us. The data below represents the number of calories per serving. So we've given this whole giant list of data. Now, again, nothing here says anything about needing to find an average or a mean. So this question is frankly really poorly worded. But we're going to work it as if it says here, instead of create for the parameter of interest, we're going to say for the average number of calories per serving, blah, blah, blah. You guys get the idea in that vanilla yogurt long sentence. So first thing in this question asks us to do is check the assumptions and conditions for inference. So those are the things from the previous page. We need our independence, same as we have since part 6, between our different observations and our sample. We need our sample to have been done using a simple random sample. We need n to be less than 10% of our population. And we need our rule of thumb. And in this case, our rule of thumb would be that if we're not originally normally distributed, that we have a large enough sample size to have some normality, or at least to the t distribution. But since we have normally distributed, this is actually unnecessary, and our condition there is satisfied. So no reason the amount of calories in one vanilla yogurt should influence the next, especially since they are randomly selected. Nothing here to imply we're doing something other than a simple random sample. And since we don't have the population size, it's really hard to know 10% of the population. If that's 14, well, there'd be 140 different brands of vanilla yogurt. And unfortunately, we don't know a whole lot about vanilla yogurt, but we're going to have to assume this is true if we're going to continue on. So second question is the one that actually matters for, say, an exam. It says to create a 95% confidence interval, and I've fixed it now to say for the average number of calories. So we have some keyword saying we want to do our confidence interval for an average. So as always, we would go to our formula sheet. We'd go, okay, I want to do a confidence interval. It's for an average, which is another way to say, to say mean. So confidence interval. Now I need to, this just reminds me, I now need to read carefully for whether I have sigma or I don't have sigma. And looking back at the question, well, there's nothing given here except for my n. So we don't have sigma. So we're probably going to want to use that second formula, that sorry. I was just thinking about the last video and how I didn't do this calculator shortcut. Oops. But there's the formula that we would use off the formula sheet. Now, in order to use this formula, we do need an x bar and an s, which is our sample mean and our sample standard deviation, which we can get by plugging all this into our calculator and then doing 1-bar stats. So I'm going to go ahead and grab those. Whatever, I'll just leave this here. It's not cooperating. So I need to put all of these things into list 1, so I'll clear it out. And then I've got 160, 200. Ugh, so slow. Typing these in is bad. All right, I'm going to pause the video and I will come back when they're all typed in. All right, so now I've entered all those data, those bits of data. You can see here my list 1 is on space 15, which means I entered 14 things. And if I go to stat and I calculate my 1-bar stats, I've got my x bar, which is 157.8571. Notice how I'm keeping those 4 decimal places. There's going to be a lot of interim calculations. I want to make sure I have that still in there. And we're not going to grab sigma because that would imply we have a population. I'm going to grab the S, 44.7521. Cool. So we're now ready to use this formula. We've got our x bar, We have our S. We know our N. The only thing we're missing is our T, and we talked about this on Thursday. If you want to do this by hand, you find this T star using the degree of freedom formula, which is N minus 1. So our degree of freedom is 13. And then using our T table. So we go to our T table. We look for our degree of freedom. You see how it says degree of freedom here, of 13. And then I also need to have remembered what my confidence level was. It looks like we had a confidence level of, oh no, I just closed my little calculator, of 95%. So I'll go back to my table, and we want to find a 95% confidence level with this degree of freedom of 13. And it appears our T star is going to be 2.160. And now we're ready to do this thing by hand. So I've got my calculator back. I can either do this by hand, or this time I'm going to go ahead and use my calculator shortcut. So I'm going to go to my intervals. If I wanted to use the calculator shortcut for the previous video, I would have used Z interval. Now I want a T interval, so I'm going to choose that. Notice that if you use this data in your calculator and did one bar stats to get your X bar and your S, they're already filled in with all of their decimal places. Everything is filled in. The only piece that you need to edit or add in is what our confidence level is. And if you press calculate, it'll do all of this math for us. One big drawback on doing this for the means is that we can only get so many decimal places. So you can see here our two values. One is truncated to 2 decimal places, and the other one has just 1 decimal place. So 132.02 to 183.7. Now, obviously, I ran out of room to do the second part of interpreting the interval, but if we were to interpret this interval, we would say we are 95% confident that the average number of calories in a serving of vanilla yogurt is between 132.02 or 100 and 183.7 calories. And then even our idea of duality persists in part 7, right? So the next question here says, a diet guide claims you'll get 120 calories from a serving of yogurt. Does the confidence interval support this claim? So we look and we say, how does 120 compare to our interval? And just like in part 6, we see 120 is not within the bounds of my interval. It's outside of my interval. So that leads me to believe that there aren't 120 calories in a serving of vanilla yogurt, right? Since our interval doesn't include so it seems in that case that the true value is probably something larger based on our interval. All right, so that was another example of a T interval. This one having that added bit where we had to go calculate our mean and our standard deviation instead of them being given to us.